Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR NET and GATE physics exam. So I hope that the discussion which we have done till now in our previous classes and the discussion we will be doing today, all that will be getting clear to all of you. But in case if there will be anybody having any doubt at any point, whatever we will talk about today in the session, you can surely let me know about it and we will try to consider those points. So first of all, I'm going to show you the slide regarding the latest offer which is going on Unacademy, as per which you will be able to save more, and the offer is just for the limited period of time. So it is valid till 15th July, and if you don't want to miss it, you can take your subscription today, and you just have to use and apply the code that's Anjali Live as mentioned here on the screen to grab this offer. Even if any of your friends want to take the subscription, you can share this information with them to let them know about the offer so that they will not miss it and they will be able to grab the offer as well and will be able to save more. Also guys, in these days we are gonna have so many new courses starting on Unacademy. So if you don't want to miss these courses and you want to join and attend the sessions of these important courses from the beginning, and you want to know about the important tips and tricks, then in that case you can take your subscription today and start your preparation under the guidance of top educators. Other than this, what are the benefits you will get if you will be taking the Unacademy Plus, Iconic or the Lite subscription? So guys, you can have a look at this one, like the slide which I'm showing you right now. It will be helping you to know more about the difference between the Unacademy Plus, Iconic and the Lite subscription, so that you will not be missing any of the important points and you can easily get to know that which subscription you find more beneficial for yourself, right? So that will be helping you this way. Also guys, if I'm going to talk about the other important thing here, I would like to tell you that is regarding the notes. So now we are even having the notes available on the learning app. So if anybody will be taking the Unacademy Plus or the Iconic subscription, they will also be able to check out these important notes and they will be able to find the important notes like in the Unacademy learning app. Other than that, they will be able to join and attend the classes of well-structured and well-planned courses by the top educators. Okay, let's go ahead for the further discussion. Here are a few more slides I'll quickly show you, and then we are ready to start the discussion about classical mechanics, which we are going to cover today in this session. So this is about the Unacademy learning app. This is about the session itself. Here you are going to have some details about me and then something related to Unacademy learning app, which is the community feature, which will be helping you to get the latest updates, to know about the important things like the new courses and all those, which will be helping you to stay updated and not miss anything. Okay, now let's go ahead for doing the discussion about the classical mechanics. So as you know guys, I am doing the discussion in these sessions in a way like I'm going to talk about the important questions and then we talk about some of the tricks related to the questions which you can apply to solve them, or we talk about the method, the procedure, the concept involved and all that part. So this is how you will simply be able to do the best preparation for your upcoming exam for the various subjects. And I hope everybody has checked out the sessions I conducted before this one. So even if you didn't attend it live, you can check out the recordings of the sessions so that you will not be missing anything and you will have the idea about all those important concepts which you can expect to be there in your upcoming exam, or how they can ask you the question related to a particular topic. Okay, let's start the discussion about the classical mechanics now guys. Here is our first question which we will consider, and if you will have any doubt, you can surely let me know in the comments, or if you will not be familiar with the concept or the tricks, I will let you know about that. Okay, so don't worry. So I'll wait for your reply for just some time and then I'm gonna continue the discussion, but I hope you will be able to work on it too. So here we are gonna have our first question now. It's here, it's here, it's here. The energy of a one-dimensional system governed by the Lagrangian L is equal to half m x dot square minus half k x to the power 2n, then where k and n are two positive constants is E naught. So they said like, okay, the energy of a one-dimensional system, then comma, the statement, then expression, then again comma, is E naught. So they are talking about that energy, that it is E naught, right? The time period of oscillation tau satisfies. And the options are tau proportional to k to the power negative 1 over n. If something will not be clear to you guys, you can surely mention it. I'll read it for you. Tau proportional to k to the power negative 1 over 2n, e naught to the power 1 minus n divided by 2n. Option C is tau proportional to k to the power negative 1 over 2n, e naught to the power n minus 2 divided by 2n. And D is tau proportional to k to the power negative 1 over n, e naught to the power 1 plus n divided by 2n. Try it now and let me know as you will get it done. And if in case there is anybody having any doubt, you can surely let me know about it. But if everything is clear, then that's great. So here they have given you Lagrangian, right? The Lagrangian in general is what? We all know it's going to be T minus V, kinetic energy minus potential energy. So that means you also know that the kinetic energy in general is half mv square if you want to write it in terms of velocity. So this is representing the kinetic energy term, while this one will be your potential energy term, right? So in this case, we have the potential energy as half k x to the power 2n, right? Now the next thing, if we are going to talk about the next thing here, what is that? That's going to be the time period of oscillation you have to find, right? And its dependency on E naught and K you want to check out. So if you are going to consider that part, what we have to do then? Do you know about the steps? If yes, that's great. You can try working on the steps you know, but otherwise I'm going to tell you the steps you have to take. So there is action angle variable, which is J, which is equal to integration P dq, right? And P is equal to what? In general, in classical mechanics, it is root 2 m E minus V. Now, V is what? Which you already have. And what is E? So, total energy, for that we consider let at x is equal to, you can take any value randomly, like you can take it C, you can take it B, you can take it A, U, W, whatever is not there in the expression, you can try to consider that any notation. So I'm taking x is equal to, is the A there? No. Okay, I'm going to take A. So I'm going to say potential energy is equal to total energy. So that means my total energy will be half k a to the power 2n, right? Now in this case, what about the position coordinate? That was x is equal to a, I have placed here. So even when you will become perfect in this approach, you can just simply take or find the value of x and you can replace it at the position coordinate place. But if you are just starting this, okay, to work on this method, I would say, okay, go step by step. Once you will become perfect and have more confidence On this approach, you can just quickly take the steps like whatever you want to do and how you find it easy and less time taking. Okay, but you should not make any mistake there. So it is going to be 2e divided by k to the power what? 1 over 2n. That's a. Okay, now in this case a was showing you the position coordinate, right? So in this case what you have to do from the momentum part, this is a kind of trick. So it's not a direct and the detailed approach, but it's gonna be a kind of trick which is gonna help you to save your time, right? So in this case I'm gonna place just root 2 me from here. That means e to the power half. So if you are starting to work on this method, you can write root 2 me complete term, or otherwise just write e to the power half. Okay, it is j is proportional to this value. And the other thing you have to consider is e to the power 1 over 2n and k to the power 1 over 2n. So that's going to be k to the power negative 1 over 2n, right? Now, you can also have a look at the options, like are the power of k same or different in all the options. So you can see in two of them it's same and other two of them it's same. So that means just with the k dependency, like the j dependency on k or the time period dependency on k, we can't find the answer. So we have to do it completely. This expression is just giving you the dependency of j, which is action angle variable, on energy, and the k, which was the part of potential, right? Now next thing, so time period is nothing but delta j over delta e. This is the time period formula in terms of action angle variable. So what I have to do in this case, I just have to differentiate it with respect to e, and that's gonna give me e to the power. See, whatever constant we will have as in the power, it will come in front, but we don't need it. Reason behind that, we just want the dependency on e. So even we can save our time at this point, and it's going to give me e to the power whatever it is minus 1. So it will give me 1 over 2 and minus 1 over 2. Okay, because half minus 1 will give me negative half. So this will give me 1 over 2, 1 over n minus 1, right? And k to the power negative 1 over 2n. So this is going to give me 1 minus n divided by 2n. Okay, for e dependency, 1 minus is n divided by 2n, where it is present. It's in option B. Okay, so your option B is going to be the correct option then. And even you can see the other dependency, that is k to the power negative 1 over 2n. We will also take more questions from this part, this section, and based on the trick. And let me just tell you one more thing. From this section, whatever questions we had in the previous years, all those questions are just simply based on trick. We don't need to go with the detailed approach or the steps, because detailed approach is nothing, just you have to solve complete integration on this part, and then you will find j, and then you will get the time period or frequency, whatever they asked you to find. And that's a little bit time taking because you have to work on complete integration. But the approach I have shared right now, it's quite quick, it's less time taking, it's simple, and it is like just you look at the expression and you reach to the answer. So it's so quick, right? Let me just give you the next question now, but if in case you will have any doubt anywhere, you can surely tell me. Our next question is this. Let's see how many of you can solve it, because somewhere it's related to general concept but also from classical mechanics. So let's see how many of you will be able to catch it. Okay, that's important. Consider a set of particles. And as you know, I mostly consider the questions from previous years. So it is expected like everybody or most of you will be familiar with those concepts. But if no, you are going to get to know in the session. But if yes, that can help you to practice, to revise, to know exactly what approach you are using. Is it the one, or are there more ways of solving it, and what will be the best way, right? So you all can consider that part too. So it's going to be consider a set of particles which interact by a pair potential V is equal to AR to the power 6 and where R is the interparticle separation and A is greater than 0. Interparticle separation and A is greater than 0 is a constant if a system of such particles has reached, here is a hint now, let's see how many of you are gonna catch it, viral equilibrium. The ratio of the kinetic to the total energy of the system is kinetic to the total energy of the system is. Options are 1/2, 1/3, 3/4, and 2/3. So consider it now and tell me what is the right answer according to you. If you can't relate it or you are not able to get like what will be the right option, I'll be helping you in that case, guys, but I want you to at least try working on it and to tell me what do you think will be the correct option. So consider a set of particles which interact by a pair potential which is V is equal to AR to the power 6. Now when you read this question statement, right, so there is a hint for you, that's this virial equilibrium. So what it tells you that you can use the virial theorem here. Now what is that? So since they have given you the potential, okay, so how your average kinetic energy will be related to the average potential energy, it will be n/2 the average potential energy, right? So in this case what will happen, what is n here? So n is basically the, if V is proportional to R to the power, so that power is n. So in our case it was 6. So it's going to be average kinetic energy is equal to 6/2 times the average potential energy. And this is how you are just going to get 3 times the average potential energy. So this is the virial theorem, basically this expression, okay? So once you got to know about it, now you know like if you will have the potential dependency on R and average potential energies relation, that how they are related to each other. And this is how average kinetic energy is equal to 3 times the average potential energy. And total energy is equal to the kinetic plus potential, and you know kinetic plus potential. So when potential, average potential, you will find it will be 1/3 of the average kinetic. So if I will plug in here 1/3 times average kinetic, it will give me 4/3 times average kinetic energy. So this is how total energy is related to average. Question is asking us to find the average, the ratio of the kinetic to the total energy of the system. So I just need to find T over E, and that will be just 3/4. So our right answer is option C, which says 3/4. That's your right answer. Please tell me if in case there is anybody having any doubt. And if no, I'm going to give you one question now, which is related to the first question, the one before this one we have done. I think now everybody should be able to do it, but if no, I'll again be helping you to relate the steps. But I hope you are now familiar with this approach because we just now talked about it. A particle moves in the one-dimensional potential, which is simply Vx is equal to alpha x to the power 6, where alpha is greater than 0, is a constant. If the total energy of the particle is E, its time period in a periodic motion is proportional to. Options are e to the power negative 1 over 3, e to the power negative 1 over 2, next is e to the power 1 by 3, next is e to the power 1 by 2. So, in this case, what they have given you? The potential dependency on x, right? Now you have to find what? The time period dependency on E. So in that case, what will happen? In this case, it's going to be the t, like if we are going to talk about this one. See, the action angle variable will be proportional to the e to the power half because of root 2 me as we talked about it. And the other thing is e to the power 1 over 6, right? So you know that what we are going to do, we will consider that at x is equal to a, let's say the potential energy is equal to the total energy, and from there you will get the position, that is x or a dependency on the e. So that will be e to the power 1 over 6. I have already mentioned the steps here, so similar things we are going to do right now. Now it is going to give you the dependency e to the power 4 over 6, which is 2 by 3. And now since you want to find the time period, t is proportional to delta j, equal to delta j over delta e. So it will be 2 by 3 minus 1, which will be giving you negative 1 over 3. So hence your right answer is option A, which is the correct one. That's how you can find it. Let me know if in case there is anybody having any doubt. We can consider that part, but if everything is clear, that's great, great, great. Let me know if something is not getting clear, otherwise I'm going to take the next question. So this is how, guys, we will try to include more and more different type of questions here, so that you will get to know about the approach to solve them, what type of questions you can expect in the exam, and that's all will be getting clear to you. The Hamiltonian of a classical one-dimensional harmonic oscillator is h is equal to 1 over 2 p square plus x square, comma, in suitable units, the total time derivative of the dynamical variable That's going to be p plus root 2x is. Options are root 2p minus x, p minus root 2x, p plus root 2x, x plus root 2p. Try it now and let me know what do you think will be the right answer. Otherwise, I'm going to talk about the steps you have to follow and which will be helping you to get the answer for this question. So it is the Hamiltonian of a classical one-dimensional harmonic oscillator. The Hamiltonian is given. The total time derivative you have to find for this dynamical variable. So if you're going to talk about the total time derivative, it is d by dt. The of a, let's say this is a, okay, the variable which is given p plus root 2x. So it will be equal to the Poisson bracket of a with h plus delta a over delta t. Since the variable is not dependent on time, so partial differentiation with respect to t will be 0. And Poisson bracket of a with h will be what? The first function partial differentiation with respect to x, second one with respect to p, and minus first one with respect to p, second one with respect to x. So root 2p minus x, which is option A, and that is the correct option. Please tell me if in case there is anybody having any doubt, we can talk about it. But if everything is clear, that's great. So option A is going to be the correct option here, okay? Now you can see if anytime you have to find the total time derivative of any variable, so what are steps you have to follow and how it's going to give you the right answer. If still there is any doubt, you can just ask it in the comments. We'll talk about that. Otherwise, I'm going to write the next question, guys. A particle in 2 dimensions is inner potential, which is v as a function of x and y, is equal to x plus 2y which of the following apart from the total energy of the particle is also a constant of motion. Options are py minus 2px, px minus 2py, px plus 2py, py plus 2px. So try it now and tell me what do you think will be the right answer. If you are not familiar with the steps or the approach which you have to follow to solve it, I'm gonna help you. So this time they have given you the potential, okay? And then they are asking you to find the constant of motion quantity in terms of linear momentum, that is px and py, right? So in this case, there is also a trick you can use for this situation, while other than the trick, you can also use the detailed approach. Now, what is the detailed approach? It's simply the V with the H Poisson bracket like you have to find, and you have to equate it with 0. Okay, and that's how, like, if it is a constant of motion, not for v but for the given options, because you want to check out for the options whether they are constant of motion or no, right? So in that case, for the options one by one, we can check out their Poisson bracket with the Hamiltonian, and if it is equal to 0, then in that case it's going to be the constant of motion, or otherwise no. So here, if I'm gonna talk about the trick, for the detailed method, you have to check out for each and every option until and unless there is any option which is satisfying this condition. So that's again a quite time taking thing if your first option is not correct, or the first option you're going to check for is not satisfying this condition, then it will be taking more time. You have to check out for other option, next and next. But if you are going to do with the trick, so it's so simple and easy. What is the trick? You have to write the corresponding linear momentum like px and corresponding linear momentum like py here. Interchange their coefficients like 2 here and 1 here. And change any one of the signs, means either this sign or this sign. So I'm going to change center sign. That will give me 2px minus py. Is it in the options? No. But if I will change this sign, then it will be py minus 2px. Is it in the options? Yes. So option A is the correct option then. So the trick is quite simple, while as the detailed method I have told you, it will be taking a little bit time. So either you can do that way or with the trick. It's up to you. Let me just give you the next question now. Let's do this one. It's easy, but mostly students make mistake in this one. A particle moves in 2 dimensions on the ellipse equation of ellipse is given as x square plus 4y square is equal to 8 at a particular instant it is at the point which is x comma y is equal to 2 comma 1 and the x component of its velocity is 6, its suitable units. Then the y component of its velocity is. Options are -3, -2, 1 and 4. Try it now and let me know what do you think will be the right answer. If you will have difficulty in considering it, we will talk about it then. But if you can find it and you know what is the right answer, you can surely let me know what is the right answer according to you. Tell me guys if you are gonna get it. So actually in this case they have given a particle moves in 2 dimensions on the ellipse. Okay, x square plus 4y square is equal to 8. Now at a particular instant it is at the point x comma y is equal to 2 comma 1 and the x component of its velocity is 6. Then the y component of its velocity will be 1. So for the velocity part you have to differentiate the given equation with respect to time. So that will give you 2x dx over dt, which is x dot, plus 8y dy over dt, which is y dot, equal to 0. Now x is 2 and y is 1. So 2 to the 4, x dot is what? That is x component of velocity, which is 6, plus 8, y is 1 and y dot is equal to 0. Okay, so y dot is equal to what? That's negative 24 divided by 8, negative 3. Hence your right answer is option A, which is the correct one. Very good morning, Anjana. Done. So let me know if in case still there is anybody having any doubt, we can consider it. But if it is clear, I'm gonna give it the next question then. And if something will not be getting clear to anyone, guys, you can just mention your doubt in the comments. Canonical transformation relates the old coordinates which are small q comma small p to the new ones which are capital Q comma capital P by the relations Q is equal to capital Q is equal to small q square and capital P is equal to small p divided by 2 small q. The corresponding time independent generating function is options are capital P over small q square capital P. Option C is q square divided by capital P, and option D is qp square. Try it now and let me know what do you think is the right answer. If you will not be getting it or you don't know what steps needs to be taken, I will help you in that case. Mention it, guys, whatever is the right answer according to you. Very good, Anjana. But I will tell you the steps and I will tell you like what you have to do to get the answer or whether it is correct or no. So actually they have given you the relation between old and the new set of coordinates. Other than that, they are asking you to find the generating function. So here comes the point. There are total 4 types of generating functions we are generally gonna have. Now how to consider those 4 types, let me just quickly tell you. So there is going to be first function, like you can write small q, small p 2 times, then 1 time, capital Q, capital P, capital Q, capital P. This gives you the information about all the possible generating functions, and these are the functions of which coordinates, like that's what you get to know, right? Once you got to know about it, now what? The next thing is that whatever is not present in a particular function, we write the formula for that. For example, small q is there, but small p is not there, right? So you are going to write small p. And capital Q is there, but capital P is not there. So you're going to write the formula for that. Here, small p is not there, capital Q is not there. Small q is not there, capital P is not there. Small q is not there, capital Q is not there. Next thing is delta F over delta small q. That will be the formula. And remember one more thing, QP. So your first and the last terms expressions will be negative while the other ones will be positive. So this one will be negative, this one will be negative, this one will be negative, and this one will be negative. So it's going to be delta F over delta Q, but the particular type of function only we have to consider. So if I'm going to call them 1, 2, 3, 4, so I'll say 1 here, 2 here, 3 here, and 4 here, right? And here 1, 2, 3, 4. Done? So you know that which one will be positive and which one will be negative. So accordingly, you can just allot the sign as I have just mentioned them here. Now next thing. If you will see the options, your generating function is a function of a small q and capital P. So where we have the function of a small q and capital P. Second one, but that's okay even if you are not thinking about what kind of generating function it is. Is it first kind, second kind, third or fourth? That's all right. Why? Because once you got to know it is a function of a small q and capital P, now what formula you have to write? A small p formula and capital Q formula, whichever is there. Not that, but what is not there, for that we write the formula corresponding to generating functions. So this one, delta F over delta Q, and this one, delta F over delta capital P. Now, in this case, what will happen? The small p, do you want it in the final answer? No, it should not be in your generating function. So that means, can you replace the small p with the capital ones? So the answer is yes. Capital P times 2Q, and Q will be root Q. So capital P 2 and root Q. Now you will integrate it for this dq. So it will give you the Q here, which is again, or you can keep it like this. Let me just write it again. It's simply going to be small p value 2 capital P small q, right? So it will give me 2 capital P small q and dq and integration, and that is F. So that is going to give me 2p q square over 2, right? So 2 cancelled out, I'm just going to get pq square plus some constant, okay, is equal to F. Now other than this, for this one, if I will do the cross multiplication and integration, I already have the value of capital Q in terms of a small q, which I want in my answer. So I'm going to plug it in here. It will give me q square and capital P after integration plus constant, let's say C1, is equal to F. So in that case, what will happen? You can see q square p, and constant is there, but I don't need any additional term, and even I didn't get in any of the expressions. So that means my generating function is q square p, that is in option B, and that's the right answer. Please let me know, is it all right and clear and everybody is just going to get it or no? If still you will have any doubt or difficulty, we will talk about it. But if everything is clear, then that's great. Tell me. Done? So what is the right answer? Option B. If it is clear, I'm gonna give you the next question now. That's great. It's a. Okay, we need to write it here. Okay guys, next question. The Hamiltonian of a simple pendulum consisting of a mass m attached to a massless string of length L is h is equal to p theta square over 2ml square plus mgl 1 minus cos theta. If L denotes the Lagrangian the value of dl by dt is what? That's what you have to find. Options are negative 2g over L p theta sine theta, negative g over L p theta sine 2 theta, g over L p theta cos theta. L p theta square cos theta. Try it now and let me know what is the right option according to you. If you will not be getting it, I'll help you in that case. But if you will get it, that's great. That's great. So actually guys, in this case, Hamiltonian is given and you have to find the total time derivative of Lagrangian. So we have already discussed one question based on this total time derivative concept. I think you will be familiar with it now, but not just that. Here you also have to be careful about few more things. And if you are the one like who doesn't know about it, I'm going to help you in that case to know like what are those other things you also have to take care of while working on different type of questions. So I'll be talking about that too, but I'm gonna give you some time right now to consider the steps and to solve it. Waiting for you to work on it guys, otherwise I'm gonna start the discussion. Okay, so Hamiltonian is given. First of all, we have to write the Lagrangian with it. Do you know Hamiltonian is kinetic energy plus potential energy while Lagrangian is kinetic energy minus potential energy. Hamiltonian is p square over 2m, but the Lagrangian, like in the kinetic energy part, but Lagrangian is half mv square. So that's going to be m is just simply ml square because if you will compare the kinetic energy of Hamiltonian with the p square over 2m, so you will get the m as ml square. So Lagrangian must have half mv square. Very good, Anjana. Even I'm going to tell you whether it is right or not. So let's have a look at the steps. So initially we are finding the Lagrangian. Okay, for that I'm going to write half mv square form. So that is m is ml square and v square means the theta dot square, right? And then minus potential energy, which is minus mgl 1 minus cos theta. Now once you are going to consider this part, now in this case, so you are going to find total time derivative of Lagrangian. So it is what? dl over dt is equal to the Poisson bracket of L with h and partial differentiation of delta L over delta t with respect to time. This will be 0 because the Lagrangian don't have the time term directly present in it, but this one will give you some value. So what you have to do, you are going to simply do it like delta L over delta theta, then delta H over delta p theta, then minus delta L over delta p theta, and delta H over delta theta, right? But if you will see in the Lagrangian, you don't have the p theta present. So what you have to do now, you have to just write it in the same way how we have taken, or we already have, the kinetic energy of Hamiltonian, which is simply p theta square over 2ml square. So when you consider it and when you differentiate it with respect to p theta, you will get the same thing there. But let's do it step by step. So delta L over delta theta, you have to differentiate this part. Cos theta will be minus sin theta, minus minus plus. So minus there, mgl sin theta you will have, right? With a negative sign. Now, delta h over delta p theta will give you just p theta over ml square. Next, minus delta L over delta p theta will give you what? As you know, like even if the kinetic energy you are writing in terms of theta dot, you have this. But if you will write it in terms of p theta, you will have this only. Or just to verify, you can do one thing. You know that the Hamilton's equation of motion says theta dot is equal to delta h over delta p theta. So from here you can get the theta dot and p theta relation. Once you will get it, then plug it in here and you will see that it's giving you same kinetic energy which you had in the Hamiltonian. So even if someone is not sure about this thing that it's going to give you same, you can just do it with step by step and plug in the value and you will find like, oh, it's going to give you same, right? Next thing, once you're going to get that, now when you will differentiate Lagrangian with respect to p theta, you will get same p theta over ml square. What about delta h over delta theta? That will be just negative of cos theta. So it will give you negative sin theta, negative, negative, positive, mgl sin theta. When you will simplify it, cancelled out, cancelled out. 1l will get cancelled out, so no power there further. And then you are going to have negative of 2 p theta g over l. So negative 2g over L p theta, where it is, and I missed the sin theta part, so let me just write it here too. 2 p theta g L sin theta, that's in option A. Can you see that? So your option A must be the correct option and that is the right answer itself. So right answer is option A, not option C. Okay, so be careful about it, whatever mistake you made while working on this question earlier. Now, I hope you are able to get it, like what was the mistake you made and where you need to focus more. Still, if you will have doubt, you can tell me. But if it is clear, that's great. I'll be giving you the next question. Done? Very good, Anjana. Let's take the next one. Two particles of identical mass move in circular orbits under a central potential VR is equal to half KR square. Let L1 and L2 be the angular momenta and R1, R2 be the radii of the orbits. Respectively. If L1 divided by L2 is equal to 2, the value of R1 divided by R2 is, options are root 2 or 1 over root 2, or it's gonna be 2, or is it 1 over 2? So here what you have to do, you need to find the ratio of R1 and R2 when you have the ratio of L1 and L2. What is L1, L2? That's angular momenta. Okay. So here guys, first thing you have to notice is this question is talking about angular momenta as well as central potential. So in any such case, we use the effective potential, which is simply J square over 2mr square. Okay. And then plus given potential, which is VR. So that's what you have to use here. And when you are going to consider it, then you are going to have this expression. Once you got this one, now you have to find the equilibrium point. For that, you are just simply going to differentiate it with respect to r and equate it with 0. So it will give you J square over mr cube with a negative sign here, plus that's going to be kr squared, so that will become just kr because 2 will get cancelled out, equal to 0. Once you got it, now you will get J is proportional to r to the power 4. Once you got that, sorry, it's J square, so J is proportional to r square. J is simply the angular momentum there, but here in this question they are using the notation for angular momentum to be L. So if I will say L1 over L2, that should be equal to R1 square over R2 square. So I'm taking the square root there. I'm going to get R1 over R2. It will give me root 2 for the R1 divided by R2. Hence my option A is the correct option. Just see, are you getting the same thing, or are these steps getting clear to you or no? If no, you can tell me, but if yes, that's great. So simply whenever your question will be talking about circular orbits or angular momenta, you have to use the effective potential, and this is how you will be able to get your answer. Tell me if in case there is anybody having any doubt, we can talk about it. Okay, that's great, Anjana. So we will be keeping it this much right now in this session, guys. And if in case there is anybody having any doubt, you can surely let me know about it. In the discussion we have done till now, if any point didn't get clear to you, something you want to ask, you can just let me know. But if everything is clear, that's great. So today we have talked about so many important concepts and the points related to classical mechanics. This way we will keep on doing the discussion about the other concepts too in upcoming days. Other subject discussion will also be there. Also guys, as I've told you about the latest offer which is going on Unacademy, so as per which you will be able to get the great discount in the total subscription amount, and you just have to use and apply the code Anjali Live as mentioned here on the screen to grab this offer. And even if any of your friends were waiting to take the subscription or want to start their preparation under the guidance of top educators, you can share this information with them too. Let them know about the code, that's Anjali Live as mentioned here on the screen, and the offer is just valid till 15th July. So in that case, if anybody don't want to miss it, they can take the subscription. Also guys, here is the information about the benefits you will be getting if you will take the plus, iconic or the light subscription. If you will take plus or iconic subscription, you will be able to check out the important notes as well, okay, which are available on Unacademy Learning app. Okay, so all these things I hope guys will be helping you a lot to know more and more about the important things. Along with that, to stay updated, along with that, in upcoming days so many new courses by the top educators will be starting on Unacademy, which will be helping you a lot to take your preparation to a very good level. So guys, let's keep it this much. Thank you so much everyone for joining this session. If you will be taking the subscription, use and apply the code Anjali A Live to get the discount in the total subscription amount. Thank you everyone. Thank you so much everyone. Thank you.